Consider this matrix for transformation T and the matrix size of 4 cross 4. There are 4 options. There is a non-zero vector which is not in the image of T. Option B, there is non-zero vector which is in the kernel of T. Option C, there is a non-zero vector which is not in the kernel of T. And option D, 1 1 1 plus kernel T represent the straight line. So if kernel T, for example option D, if kernel T is a single element means a single vector, and we will add this vector. If we are adding these two vector, addition of two vector is again a vector, and a vector represent a line. So in most of the case this will represent the vector if kernel T nullity of T is 1. If nullity is 0, then only 0 vector. After adding in 1 comma 1 comma 1 1, we will get again this element, and single element in R4 will represent a line. So first, in all 4 options we will try to find what is the rank and nullity of this matrix. So if we apply elementary row operation, we will find that there are 3 pivot element. So rank of this matrix is 3 and nullity is 1. Because of this is Venn diagram structure for this linear transformation. Suppose this is a basis, and basis for image, you can consider this is a basis, a very small portion. This is a basis, and this is image set, image of T. So 0 vector goes to 0. That's why 0 vector outside the basis elements, because of if 0 is in any set, then set becomes linearly dependent, and we know that basis is linearly independent. So 0 is outside, but 0 always in the image set. Because of rank is 3 and dimension of codomain is 4, if we consider a linear transformation T from R4 to R4, this is not same as dimension of codomain. That's why we have a single element. We have at least one non-zero element which is not in the image of T. So option A is true. Also, nullity is not same as dimension of domain. It means that there is a non-zero vector which is not in the kernel of T. This option C is also true. There is a non-zero vector which is in the kernel of T. Because of nullity is 1, it means that there is a non-zero vector which is in kernel of T. This is option is true. Now we try to find out option D is correct or not, because 1 1 1 1, this is a single vector, and kernel T is containing a non-zero vector. So sum of these two vectors will again a vector, and a vector represent a straight line. So option D is also correct. All 4 options are